In this video we will learn division of integers. So we know that division is the inverse operation of multiplication. For example, 4 into 6 is equals to 24. So 24 divided by 6 is equals to 4, or 24 is divided by 4 is equals to 6. Now some point we have to remember. So first point, when we divide a negative integer by a positive integer, so the number will be negative. Suppose minus 72 divided by 9 is equals to minus 8. Then when we are dividing positive integer divided by negative integer, so answer is also in negative. Okay, when both integers are negative, so answer will always in positive. Now some other points are, suppose two numbers are integer, so a divided by b may or may not be integer. For this I am taking an example. Suppose 9 and minus 2 are integers. Okay, so when I divide 9 divided by minus 2, so answer in decimal minus 4.5, which is not an integer. Okay, so this is the closure property is not satisfied for division. Okay, move on the next property. Division of integer is not commutative. Suppose I am writing 5 divided by 3 does not is equals to 3 divided by 5. Or you can say that 8 divided by 2 does not is equals to 2 divided by 8, because the answer will be here 4 does not is equals to 2 upon 8. It means 1 upon 4, and it will be 0.25. So 4 does not is equals to 0.25. Okay, it means division of integers is not commutative. Similarly, division of integer is not associative. Suppose I am writing 6 divided by 2 divided by 3 does not is equals to 6 divided by in bracket 2 divided by 3. This answer will be in decimal, so this answer will be different from this. So we can say that division of integer is not associative. Okay, then move on the distributive law over addition. So it cannot be possible. Suppose I am writing 15 divided 3 plus 5 does not is equals to 15 divided by 3 plus 15 divided by 5. You can solve. This is the 5 plus 3 is a, so it becomes 8 in the right hand side, and there 5 divided by 8. So answer may differ from this. So we can say that we cannot apply distributive law over addition. Now next point is, suppose any integer divided by 0 is not defined. Suppose I am writing 5 divided by 2, it means not defined. Okay. Next point, 0 divided by an integer other than 0 is equal to 0. Suppose 0 divided by 7 is equals to 0. 0 divided by minus 8 is equals to 0. But 0 divided by 0 not defined. Okay. Move on the next point. Next point says any integer divided by 1 gives the same integer. Suppose I am dividing 8 divided by 1, so answer will be 8. 9 divided by minus 1. So answer is minus 9. So we can say that any integer divided by 1 gives the same integer. Okay, move on the next point. Any integer divided by minus 1 does not give the same integer. Suppose 6 divided by minus 1. So answer will be minus 6, which is does not is equals to 6. Similarly, 9 divided by minus 1 is equals to minus 9. Minus 9 is divided by minus 1 is equals to positive 9, which is not is equals to minus 9. Okay, here you can see that minus 9 divided by positive 1, it gives minus 9, which is equal to minus 9. Okay, now last point, if A is greater than B, then A divided by C, then B is always greater than B divided by C. If C is a positive and A divided by C is less than B divided by C if C is negative. So for this we will take an example. Here suppose I am taking 20 and 10. So let's say 20 is A and 10 is B and C is equals to 2. So here 20 is greater than 10 and C is positive. So A divided by C is always greater than B divided by C. So here we just put the values. So 20 divided by C, that is 2, is greater than B divided, that is 10 divided by 2. So here will be 10 is greater than 5. Now you can see that suppose C is negative, C is equals to minus 2. So A is 20, B is 10. Okay, so C is negative for this. So A is divided by C is always less than B divided by C. A is 20 divided by minus 2 is less than 10 divided by minus 2. So 20 is divided by minus 2 is equals to minus 10 and here will be minus 5. So we know that minus 5 is greater than minus 10. So we have to put this sign. So this had been proved.